Oh, good morning, good afternoon in some places of the country, but I think I'm ready for the happy hour. What do you think? Right? Exactly. So today, I'm your presenter on the wireless networking and integration with medical equipment. Just going to give you some of my background. I started 25 years ago working at Motorola, about 12 to 13 years in the IT department as a consultant. Right after that, I worked for the Arizona State University for about another 4 or 5 years, again in the IT department as a consultant. Since 2006, I've been working for Banner Health, and I've been doing numerous tasks and projects. My latest is I'm the site senior manager for Banner Boswell Medical Center. This facility is a 503-bed facility located in Sun City, Arizona. Since 2006, I also had a part-time career teaching at the community college and in the area of Cisco. So I'm a Cisco certified academy instructor, and I've been teaching these curriculums, anything from 140 through 170, and this is to assist the professionals that seeking that diploma or certification. I also teach the fundamentals of wireless LANs, which this morning that's what it's all about. You know, giving you guys an overview of the wireless and how that applies to the hospital facilities and medical equipment. So before we start, let's start with a question. Who can answer this? Find a job you love and you will never work a day in your life. Any hands? There's only 3 options there. So what is it, like 33%? Did you get that wrong? Anybody? Come on. Yes, ma'am. Confucius, that is correct. Thank you. Would you please give this to the lady behind? Great, thank you. Excellent. So what we're going to see wireless, how it is redefined in today's industry. You know, we don't see wireless LANs like a regular LAN, local area network, because we're not attached to a wall anymore. We have mobile devices, and that is what's important in our field. You know, wireless networking provides all the features and benefits of the traditional LAN technologies without the limitations of wired cables. And sometimes, you know, now it started to be less cost in those installations. The freedom to roam while you're still maintaining connectivity. For example, you have VoIP phones, right, and some of your hospitals. And how important is that to maintain communication among departments, among your own people, technicians? Just a brief overview. Since 2000, we saw a growth in this particular technology. Everything from start to apply this, warehousing, retail, healthcare, education, business, home. You know, nowadays, who doesn't have a wireless router at home? I bet that 9 out of 10 in this room, we have, you know, a router that is wireless. So wireless is a broad term that most users think as a single system that would allow their devices to work in a medical facility with instant connectivity. In fact, facilities, any facility, have different wireless area networks or VLANs. You know, the reason being is that you don't want to have all your medical devices in one network that will saturate the bandwidth. You also have security that take in consideration. So, you know, that is some of the items that you need to take in consideration at this time. Traditionally, each of this has had its own independent wireless network. So in practice, in a hospital, you could have from 2 to 10 wireless networks, whether it's guest, whether it's for a particular department or a particular technology that you're forwarding data through. And those are some of the wireless devices and standards that you will find as wireless or you use the wireless for. The ability of caregivers to roam wirelessly can create efficiency, lower cost of care, increase access, and improve outcomes. So as you can see, the wireless LANs are an addictive technology. And pretty much like everybody here, uses that, whether it's an iPad, your regular phone, a PC, VoIP phones, any environmental devices, nurse call, for example, that goes through the wireless. Nowadays you have infusion pumps, beds. You can pretty much have all kinds of wireless devices. Now, the key about this is to know how we're going to secure these wireless networks. And we're going to talk about that in a little bit. There is a technology called 802.11 in which we have several standards on that one. We have 802.11a, B, G, N, and the last one, 802.11ac. So, and this last one has been ratified in 2014. And we're going to talk about that a little bit, just giving you a little bit more information about that. We're not going to get deep into it, how we configure those or how are we going to set those up. But at least you have a pretty good understanding as to where we're heading and how we're going to implement those standards. Any questions at this point? Please feel free to ask any questions during this presentation. If you want to wait until the end, that's fine, but we can address it during the presentation. So this is how the wireless LANs are taking off. There is a consumer enterprise magazine that shows that in the past 6 years, wireless LAN has had an increment growth of 10 to 15% across the nation. This published by the International Data Corporation. That's a worldwide. Now, as always, you should remember that any network is only as fast as the slowest link. For example, if you're buying an 802.11ac to improve your Netflix viewing or gaming, but you only have a router that it can do 10 megabytes per second, well then right there you have your bottleneck. Okay? So you have a device that can do higher speed and bandwidth, but when you go back to your router at home, then that would be the bottleneck and you cannot do what you need to do. So take that in consideration when you're implementing wireless at home. The Wireless Ethernet Capability Alliance, which is a WEC, is a Wi-Fi alliance, a non-profit organization, international organization that was formed in 1999. The reason that this organization was created is to certify interoperability of wireless local area networks based on 802.11. So there is that association. You can't just, let's say, we're going to have this device that is a wireless capability and put it in place. So they are in charge of ratifying that. So mobility is important, right? How important is that? I mean, you can do a lot more work by using tablets, going to all parts of a hospital by extracting information data from your servers. And you don't have to go back and forth to your desk and get that info. You can even respond. Hello? So that's what is important. Some of the benefits. Can someone here tell me why is some of the benefits of wireless LANs? I'm going to outline some of the benefits here. Mobility, we just talked about that. How about its scalability? How scalable would that have to be? That's also important. You can't just, what I'm saying is that, let's say that you have a technology. One of the biggest vendors out there is Cisco. But let's say that you have HP as wireless devices, access points, and you want to introduce Cisco. So you want to have the infrastructure that will support that without all that cost behind it, right? So that's why it's so scalable. Now, let's say that you only have 10 access points, but you want to grow to 50. You got to think ahead and make sure that you do have that infrastructure that it takes that. A lot of the access points are now power over Ethernet. So you don't have to send or place an electrical outlet right at the access point. So that's a saving cost for you. Whether you implement that at the beginning of your construction project or during that project that you are adding your wireless network. Questions on this? We can see some of the frequency bands. That goes anywhere from your 2.4 gigahertz up to 5.2 gigahertz. And we're going to touch bases in a little bit about why Banner is moving to the 5.2 gigahertz band. Any idea why at this point? Yes. So what does that do to the system? What does that do to that wireless? Exactly. So now you have an oversaturation of devices on just one network. Everybody's trying to compete your speed, your bandwidth on the 2.4 gigahertz. Therefore, we need to see other technologies or standards that will give us that at this point. And 802.11a, N, and AC will have that. You may know this, but the 2.4 gigahertz band has only 3 non-overlapping channels. Okay? The other technology, the 5.2, has 23 non-overlapping channels. So there's more bandwidth, so there's more room for your devices. Any questions? So we see different local area networks out there. We have our personal area network. We have our local area network, our metropolitan area network, and our wide area network. And all this can be added to the wireless. Here's some of the speeds that every one of those technologies and bands have. You can tell the standards right here. The 802.11a, B, and G, they are used for medium, and they using this speed up to 54 megabytes per second. So we have a metropolitan area network, and this is one of the fastest one out there. Now, 802.11ac, which just been ratified in 2014, it is said that it is 3 times as fast as the 802.11n. Anybody have heard anything about this technology, the N? They also call MIMO, multi-input, multi-output, which is just have more antennas and receivers on that. But this newer technology, the 802.11ac, has 3 times the speed and the bandwidth that the N. And you're going to see those coming up. Now, you're probably thinking, well, let's move into that particular standard right now. Well, there are some caveats to that. This newer technology will require 2 data ports in your switch. All that does to you is that you got to start thinking about what? adding more switch equipment in the back in the closets, right? Wiring infrastructure, and so forth. I mean, even though they're still wireless, you still need to have that connectivity back to the closet, back to the IDF, back to the MDF, whatnot. Okay, here's another question. Who wants to take a shot at this one? Who said victory belongs to the most persevering? Close, but not right. No. So, who said Napoleon? There you go. Pass it in the back, please. All right. So here's some good critical steps into your implementation of wireless LAN. One is, get a good print or layout of your facility or the area that you want to implement the wireless, and determine those access points placements. Okay? We talked about channels, right? Like the 2.4 gigahertz, it has 3 non-overlapping channels. Well, make sure that those do not, get on top of each other. So you do need to have that print, have a good layout of the building, conference room, facility, floor, whatever, and allocate those. And the last one, security protocols. We're going to talk about that and different types of protocols, which are so essential to this implementation. Okay, so one goes hand with the other. We have, and we call an access point as a wireless cell. So once you start adding more cells, you can create a wireless network. Now, you will see there's an overlapping between the cells for coverage. You don't want to drop your calls, or you don't want to drop at any given point in time, that connectivity. So if I'm talking on my VoIP phone and I'm moving from this conference room to the end of the hallway, if there's no coverage down there because there's a separation between the cells, my call will be dropped, or I will not hear the other person, or the other person will not hear me. Okay? That is also a good rule of thumb that you can use when you have medical devices. So let's say that you have RTLS system, and you're tracking all your devices, your infusion pumps, your wild cards, anything. You want to know where they at all the time. Well, through the wireless system or RF, you can do that. You can track your devices. Anyone in here has an RF or RTLS system in their hospitals? Is that how are you using that RTLS system? How efficiently and how often do you use that? Daily? Okay. There is a facility in Arizona, at Good Sam, where we did a test on an infusion pump that it was worthless. It was just an LVP. And we put it down the shaft, and we saw it on the screen how that device was monitored and was actual real time. We did that because, for one reason, we were getting complaints, or we were being told that sometimes our telemetry, the packs, were either taken on linen, going, with the patients, so we know where they at all the time. Now, once they exit the facility, right now we don't have some kind of a chip that tells us, hey, this device is exiting the facility just yet. But it can tell us with a 99% where that device is. Right now you can locate a device within 8 to 10 feet of where it is, which is great. How many of those expensive devices you can find, they're so small that they're in drawers, cabinets, people would just hide them because they don't want to lend it to anybody else. Or they just, get misplaced altogether. So this is the layout that I was telling you about, and every one of those circles right here represent a cell, and in between is the overlap, so we have a coverage at all time. So all the access points work on power. Once you move away from an access point, you have less power, and then if you have the next access point configured to pick your device, your end user device, it will just grab it. It says, okay, now you're on my area, you're associated with me. Okay, and this is a layout, more or less, where it tells you, okay, we're going to map these channels, either 1, 6, and 11. Those are the channels. They are non-overlap at this point. I did not bring a slide where it's showing you the 23 non-overlapping channels for 802.11ac, but it is the same practice. You do have the same layout. So before we continue on to the security part of it, I'm just going to put out there 3 scenarios. One would be a nursing home, the other one would be a home care, and in hospital. And you will see how we can use wireless devices at every one of these scenarios and with the same compatibility and usage. Okay? We do have at this time wireless sensors, environmental sensors, and on your nursing home, you will have someone that will carry a PDA, whether it's someone that you trust, whether it's a nurse that will be watching the vitals of that patient. So what happens is, let's say that a patient or someone that is in a nursing home, it has some breathing difficulties. That data will be sent to the PDA right away. Not only that, but it can also trigger a call to emergency services if that's the case. That data is also stored, whether it's local or remote, via wireless or internet. So that's the flexibility about using wireless devices. We also use these devices not as a wandering patient device, but as a patient tracking device. You want to know where and that facility is located. Maybe you want to know, how close to the nearest egress is. We have patients that suffer dementia. They just don't know where they're at. They're confused, and the first instinct is that, I'm just going to go home. I have a story on a patient that last year in one of our medical facilities, rehab facilities, that patient called the taxi. Taxi was outside waiting for the person, and it was discovered by one of our nurses because, that tracking device. So that's how you can not only save cost, of course, nowadays everybody looks at cost savings. We don't want to overwhelm of nursing staff, when you can track multiple patients with these external devices. So again, this is just to complement or to add on more information on how this external wireless devices can be used and where that information should go or will go. And you've probably seen advertisements as to, I'm falling and I can't get up, and there's an elder person just pressing a device on the chest. Immediately that goes out to 911. So that's how wireless can be implemented, not only in home care, but in the hospital. In the hospital, we have devices that can tell if the patient has been exited out of the building or they're trying to get off of bed, right? And where those announcements go, or alerts. They go to either a two-way radio, they go to your PDA, they go to a nurse call devices. Many of you are probably very familiar with that nurse call. You know, so whether you're using ASCOM, Westcom, many out there, that's how they get the alerts. They can either come in a form of a beep or maybe on a form of a text. Okay, you can use that for patient turning, maybe for rounding on a patient, whatever you want to, utilize that particular technology. So let's start looking at some of the facts and how people that are trying to be so creative and attacking our wireless technologies. There's so many malicious people out there that they want to capture that data so they can send something that it is not true, just to jeopardize the health of somebody. Maybe just stealing medical records. And you've probably seen that on the news day by day, that some facility was hacked and all the Social Security and numbers and health information was stolen. What's the reason for that? Well, one of the reasons for it is poor encryption or security. So the first one that we see here is WEP, which is the lowest form of security. And it's very easy to crack in. You can get applications from the internet that you can load on your laptop and crack this wireless security form. And you can either go to a hotspot or like coffee shop, and with your own laptop, you can give the sense to everybody that you are the DHCP server. So how much risk is that? So if I want to hack your info and you're coming into Starbucks, then you start working with your laptop, and all of a sudden I'm the one that is giving out the IP addresses. So everything that comes from your laptop to me, I can see it. And you still go out. Why? Because that will be just a middleware point on going to the internet. You will not see that. For you, it will be very transparent. But for me, I can see everything that is on your laptop. So security must be turned on from the beginning. That's no questions asked. But what type of security? You may ask yourself. We're going to see that in just a second. So some of the potential barriers that we see in technology is that when you're exchanging information among the caregiver and patient, or even between caregiver to caregiver, it will be if you don't have anything that is compatible. For example, you're running Cerner in one facility, you probably run something else in a different facility, and you're trying to connect through wireless. So that's not going to work quite well, right? Some of the health records and other systems are interoperable, so various technologies do exist, and that's when we talk about middleware. And that middleware, many times, we don't anticipate that because we don't know, and we don't know what we don't know. I mean, if you're trying to work on a new particular medical device, but they say, well, they did not disclose that you had to have a different application or a middleware in between to talk to your EMR, I mean, that's a problem from the beginning. So that's the reason that that you need to ask those questions prior to implementing new technology. You have to go through your committee, those that ratify that, okay, is this a good device? Is this something that we are heading? How many other hospitals? If you have multiple hospitals in your company, then you can start learning from good practices from others. Has this been implemented somewhere else? If not, can we trial this first? So things that you can do prior to implementing that. So here's the wireless equivalent privacy, which is your lowest encryption protocol out there. I will not recommend for any one of you using that. You're probably asking yourself, okay, so if this is not the one, which one I should use? And how do I know that my network is using the correct one? Are you part of or working with IT closely? If not, you should start considering working with IT in that area and ask those questions. What kind of security do we have? What's the bandwidth? What's the standard that we're using? Where are we heading in 5-10 years? We have the next one, which is the Wi-Fi protected access. And this one was just introduced right after the WEP. It's a little bit harder to crack, but it's still a ways to crack this one. Then, right after that, they came up with a WPA2, which is another standard of security. Many people use, at this point, this type of security enhancement. I've seen this, not in hospitals that I worked on, but I've seen this on warehouses, business offices, things like that. Areas that they should require higher encryption and security. Even some of our government using, this particular encryption and security. The last one is PEAP. It's a Protected Extensible Authentication Protocol. In combination with this particular protocol is secure password based. We also use this in conjunction with the a particular authentication protocol. Now, this one is used in your VPN authentication, and that's probably something that your hospitals and agencies are using, your systems. Again, how do we know? Talk to IT. Make sure that they do have the latest or the highest protection there is out there. That one is also good for Windows. Many of our end users use Windows, whether it's Windows 7, that's what we're using right now. We just barely moved from Windows XP, can you believe that? Into Windows 7, which out there, people are using Windows 10 already, But we got to follow, the standard for our company, and that's what, we have currently. What I'm going to tell you is that how we address, I'm from Banner Health, so how do we address that? So we start moving from the 2.4 gigahertz spectrum, which I already mentioned that is very saturated, and force the devices, those that have the capability to go into different standard or different bandwidth, to use the 802.11a and N, and that way, there's less saturation. They have more bandwidth, more control to it. As I mentioned, these standards, they have 23 non-overlapping channels. So we see in the future that this will be enough for our company. Maybe in 5-10 years from now, there's a new technology out there that can give us more speed. As always, we're hungry for that. Every time that you probably go to Fry's Electronics or any of those companies where they sell you technology, the first thing is like, which one's faster? This one? Which one has more capacity? Well, this one has 1 terabyte, but this one has, so you're always looking for what? Bigger, better. Just remember what you have behind, and how you connect your wireless device to the network. We have a group which is a network that carries our network protocols, the NPI, and those are that's the division or the group that takes care of standards in which direction we go to. So whenever they tell us, hey, this is the new change, this is the new standard, that's what we all need to comply. Yeah. All right, this will be easier one. Yeah, which one? That's right. Would you just pass it up back, please? Okay, so this is some open-ended questions for you that you can take back. How connected, secure, and resilient is your health system infrastructure? So that's a big question. How is it? And the question, again, and I'm emphasized with IT because even though years back, biomed, clinical engineering, tech management, we kind of consider the redheaded stepchild. They're like, nobody wants it, this guy's right here. And IT, ooh, I don't work with those guys. But now, we need to start mingling with this. We need to start working together with them. Why? Because we're all looking for the same thing, which is patient safety. And this is what is going to take us to the next level. So that's why it's so important to work with IT. How many of you are separate from IT? Okay. It's so important that you start thinking about that. And more important that your CBET technicians and managers understand some of the basics as far as they start getting the in-service that is required, not only to know and understand security basis, but let's say if you have the opportunity to change a VLAN network from a switch, because if you have, let's say, a device that it works on VLAN 19, but then there was a change, and now that device has to go to VLAN 10, right? How are you going to make those changes? You got to call IT. But what about if you do have that capability? What about if you have the knowledge? So instead of waiting for what? A day, 2 days, a month, depending on the request, how expedite that is, right? It's been my experience that I made a request for a VLAN change, and it takes about 3 days, when you can just go into the switch and do it in 10 seconds. So to me, it is very important that the CBET technician will have that knowledge behind. I'm not saying get certification on CCNA or A+, or Linux or anything like that. I'm just saying to have that information and to know the know-how and how to do it. Do the places that send and receive your data speak the same language? That's very important too, right? Anybody can come up with a couple of examples? It's a great question. So what I hear you saying is, if you have a router that is Apple and it has the AC technology, right? But you have a laptop that does not have that capability. So you will not be able to take care of that or use that to your advantage, because it's like using let's say I'm driving a Yugo in a 4-lane highway. Well, it's only going to give me, as much as the Yugo is going to give me. But if I have a Ferrari, but I'm going on a single-lane highway and it's crowded, I can't go fast. I can't go like 200 miles an hour. You see what I'm saying?
Right, so essentially you need to upgrade the devices.
Exactly. You need to upgrade from your access end and the user end. In this point, your printers, your laptops, anything that is on the user end, and see what's your load what's the bandwidth needed, and work your way back and see where are the areas that you need to implement higher bandwidth and speeds. Whether it's a switch, an access switch, whether it's a distribution point switch, or a core router. Any questions? More questions? Some of the components and technologies out there. That way, that will be just showing you. Maybe you're familiar with them. Maybe you just don't know what is an access point. Maybe what type of antenna they're using. For different types of technologies. But just want to give you a brief overview too on the antennas. Each of the antenna has different gain and range. Some of them are directional. That means that if I have a hallway that I only want that hallway to have wireless, then I have a directional antenna, and I point that into that hallway. But in this case, let's say I have a conference area, so I'm going to use what? An omnidirectional technology, which it goes 360. So that's different technologies, different type of antennas will create or give you different beam widths and coverage. Now, you may ask yourself why I'm showing Cisco. Well, because I'm teaching the Cisco class at the community college. So I had to conform with certain things and criteria that they asked me to. That's why I have all these slides and everything. So you can see that those are like older types of access points. And these ones are probably some of the newer ones. In here, this is the one that has the multiple antennas, and I'm going to say they probably give you a 802.11n standard. You're very familiar with some of these cards. Now they used to be those type of PCMCA cards. Now they're integrated into your PCs or laptops. So it has been now, the technology is so advanced that you don't even have to have those. There's the components for an antenna. So let's say that you're having two facilities that you want to connect via wireless, and they're in close proximity. When I'm saying close proximity, is like one is here and the other one is 5 miles down the road. Right? How do you do it? Well, through this type of antennas. You align those two, you put them on line of sight, which is very important. Line of sight, with the curvature of the earth. So you need to make sure that the antennas are raised to the proper level so they can have a linkage in between the two. Make sure that no other buildings are in the way, trees, mountains, anything like that. So otherwise you will have some difficulties on connecting back and forth. And some extra accessories to connect the antennas. Some wireless enabled devices. You can see that in any hospital on your supply chain using scanners. Nowadays, we are using scanners too. When we do our inventory or when we go and track our devices, instead of just like typing it, we go with the scanner. Well, right there. It goes right into our database and save us time. On this one, we have full coverage on this conference room area. We have one AP right here on the yellow one. We have another one in red, another one in blue, and one more in green. Every one of these cells will need to be on a different channel.
So I only see 3 channels.
Right, because you'll repeat that again. As long as they're not overlapping among each other, that's the way that you can take care of those. No, channels. So it's like you have channels right here, 1, 6, and 11. And we established that those are not overlapping. If you use channel 2, that overlaps with 1, and so on. So this one, over here, you have 1, 6, and 11. We know that those channels do not overlap. And you can start over here again. See, it doesn't touch this one. And that's how you were not interfere with the next one. Okay. And that will be represented right here. And that, it's going to give you a better idea on that, on how that works. Any other questions? No? Well, thank you all for coming. And Taylor, do you have anything?
No, I think y'all are good to go. Hope y'all enjoy the rest of the day. And the exhibit hall grand opening is in just a couple minutes. And if you haven't filled out your surveys, please do that. And I think that's it. You guys have a great day.
Enjoy your day. Thank you.